-1 work done. Always try to imagine that this what I feel like a student should have an idea that, oh, I'm learning only this much. First, that clarity is needed. Yeah. Okay, there's a piston. Okay, now so there's no friction. Let's assume this is smooth. Here, pressure of gas P1, volume V1, temperature T1. Pressure V2, volume V2, temperature T2. This particular pressure, so look at this pressure V, will take it initially. So this will exert a force, no? Let A be the area of cross section of cylinder, P into A. And because of that, it has undergone displacement, delta X or dx will take it. Why do the piston will move? Quite natural. The gas, what happen, will exert force, no? Will agree all of you? Just now, KTG, we have discussed, no? The gas will exert a force on the piston. It will exert force on the walls also. I'm not bothered on the container. This is a cylinder. I'm not bothered on the cylinder. I'm bothered about force acting on the piston. Okay, now, if a force acts on a body, if the piston is having a mass m, let's assume that. What will happen to the piston because of force? It will accelerate. Then as it accelerates, the kinetic energy of the piston will increase. From where this kinetic energy is coming, the gas is doing work. So what gas? Gas is doing work. Go back to work point G chapter. An agent does work means what does it mean? He must possess energy, no? So now the gas is having ability to do work. That work done by the gas is what we are trying to define. So then let it undergo work done by the gas. TW equal to force into displacement. What is the force? Pressure into area. So this will be P into A into dx will become change in volume. So in any process, there's a formula. Work done by the gas equal to PdV. Next other thing comes. So how do you can say work done positive or negative? Very simple idea. Volume increases, work done by gas positive. Work done by the gas it is. This will be positive when volume of gas increases. Work done by the gas negative when volume of gas decreases. Means, sir, like a, suppose I did the initial, let's take, I'll move the piston towards left, X agent, I myself, I'll move the piston. So in that case, what will happen? The gas does work, negative work. So work is done on the gas. Gas does work or work is done on the gas. It's like this, work done by X agent or work is done on the gas. So simplest way for you is volume of gas increases, work done by gas positive. Volume of gas decreases, work done by gas negative. Work is done on the gas, work is done by the gas. If gas does work, positive. Work is done on the gas, it should be negative. Able to get this. So, well, it depends on path S very much because integral of P dV. Okay, let's do one thing. I will. There are two paths. We'll take it. One. Okay, there's a path A. Okay, pressure here, let it be P naught, 2 P naught, volume V naught, 2 V naught. Okay, agree this. So let's calculate the work done in different paths. This one. So first, can we write what is work done in the path AL, right? Let me call it. Work done in the path A. According to this formula. So what is the pressure? Pressure is constant. The volume changes from V naught to 2 V naught. No? Work done in the path along path A should be equal to pressure is how much? P naught. Volume will change from V naught to 2 V naught. So P naught. Simple idea. Work done along the path A is how much? P naught V naught. Work done along path B will calculate. First we'll do mathematically, then we'll see any theoretical ideas can I bring. Integral of P dV, where the volume changes from V naught to 2 V naught. Oh, pressure and volume are related here. Any equation can we bring? So expression for path B. For path B, pressure is equal to slope of that. Anybody? Slope. It's a straight line passing through origin. So slope will be 2P naught minus V naught, 2V naught minus V naught. Okay, this is the expression for pressure. Okay, let me substitute here. Work done along the path B should be P. Okay, already I substituted. So P naught, V naught, V dV. P naught, V naught, I'll take outside. So this will become V square by 2. P naught, 2V naught, 4V naught square minus V naught square. So this will be 3P naught V naught by 2. Look at work done along the path B and path A. Are they equal or different? Anybody? WA, WB, check it. Where are they same or different? So O will move like this. The extrusion, sir, how the gas will undergo, how you move pressure constant. As I can move. Sir, how you can vary pressure directly proportional as pressure as volume increase, pressure increase. As the way how I move piston. I can move in piston in such a way that pressure of gas constant, volume increases. I can move in such a way that where pressure and volume both will increase linearly. It all depends how we move piston. How they are same? Huh? How they are same? Can't you open eyes? P naught V naught and 3 P naught V naught by 2. So what is work done by the gas in the path A and path B? They are different. So therefore, shall I say work done depends on path or work done depends on path? No, for path A and path B, they are different here. Say at least what is there on the board, you should observe, no? What is there? Sir, I'm unable to see, then teacher can't help. What is there on the things? You should able to notice the symbols. Huh? Okay, now let's come that one. So what is the thing? WA is not equal to WB. We'll do one thing. I'll just write P naught, V naught. Temperature we don't know. That's what. So, sir, which process the gas is undergoing? Okay, either it can be this or this. You cannot make it to undergo both the process at a time. Am I right? I think this is a stupidity, no? Common sense. How it can undergo two processes at a time. Either it should undergo this or this one. Either you can move piston such a way that pressure constant, volume increases, or pressure volume both varying. That's what the meaning here. Huh? Okay, no. So therefore, WA not equal to WB. So what is the conclusion I can make it? Work done is different for Work done is different for different path. Agree this? This is B. Okay, shall we say that work done is depends on path or different for different path, or work done depends on path. Okay, this is about the conclusion. Okay, let's see some other things. Okay, the same graph. What benefit, what are other things I can get from this particular graph? There's a volume, there's a pressure. Okay, first let's go for work done in the path. Path B. Already we know something. No, I'll do this by not by integration, by some other method. Now, what is some other method? I will let me check the area. So what do you say? This some sort of trapezium, no? This what? WB, I'll write it. Work done path P is equal to area of trapezium in PV graph. So what is the area of trapezium? Half into base 2 V naught minus V naught, sum of parallel sides. P naught plus 2 P naught. So how much we are getting? 3 P naught V naught by 2. What about positive or negative? Volume is increasing, so therefore positive. So is this okay now? Similarly, work done along the path A. What happened all this? Not getting. Okay, we'll draw it. Now for path A, let me show it separately. Okay, this was the path A, no? Pressure constant, only the volume was changing. Agree this? So let me take. Now you see this one. So this is area, let me calculate. I think quite very simple, no? Area of square in PV graph. Now what is this? P naught into 2 V naught minus V naught. So P naught V naught. There are two approaches are there for you. If you can calculate area in PV graph, you'll get the work done. Or else, if you know how pressure varies with volume, substitute work done equal to integral P dV. There, you substitute P as a function of volume, then integrate with the limits, you'll get the work done. Okay, no? The next week, today, from today onwards to till next week, the method will be same. How to calculate work done? So what will be my approach? I'll search for area under PV graph. If I can calculate area under the curve, okay, fine, that is equal to work done. Or else I should get expression for how pressure related to volume. If I know that, if I know this, how pressure related to volume, this is what I did. No, you can see this equation. So what is this equation now? From where I brought it, I just substituted expression for P, no, because we know work done. Okay, I'll write it. Somebody is asking, sir, why you are writing? in place of P, what shall I write? P naught V by V naught, substitute there and solve and put the limits. So to calculate work done, what are the approaches you have? Area under PV graph or work done equal to integral of PdV. Any processor, any process. Now, how to check work done positive or negative? Volume of gas increases, work done positive. Volume of gas decreases, work done negative. And look at this work done depends on path S. You can see now. So how do you can say now? Now you can do one thing. 1, 2 is that. So shall I take it in here like this? Volume of gas constant. So work done, what happened? 0. So if I move like this, if I move like this, work done will be different here. So therefore, work done is independent of path, we can say. Fine. This is the conclusion which I'm giving through examples. So let's take the, once again, we'll have a broad conclusion. See, first of all, okay, a few more are there. Okay, let's